Yo, 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 let's answer the post-lab analysis questions together. Number 1, define the following terms, endothermic and exothermic. Let's start off with endothermic. Endothermic is when heat is absorbed by the system. So we should feel the reaction as being cold. Exothermic is the opposite. Heat is released by the system so we should feel the reaction as being hot. Number 2, what are the correct units for each variable in the Q equals MCAT equation? So let's start off with the variable Q. Q stands for heat, and the unit is joules, capital J. M stands for mass, and its unit is grams. C is the specific heat capacity, and it has a complicated unit, joules, divided by grams, degrees Celsius. And finally, delta T, change in temperature, is degrees Celsius. Number 3, write the dissociation reaction for calcium chloride, CaCl2. So we start off with our reactant, the calcium chloride. When put in water, it separates into its respective ions, calcium ion and 2 chloride ions. Okay, number 4. Describe the bonds that are broken and the bonds that are formed when calcium chloride is dissolved. So I'm going to be categorizing it for y'all. So let's start off with the top row here as broken bonds. And the bonds that are broken are the bonds between calcium and chlorine. And the new bonds that are being formed would be the bonds with calcium. So I'm going to write down bonds formed. Bonds between calcium and the water molecule. And then the second one would be bonds between chloride ions and water molecules. Now we're going to illustrate this with number 5 and number 6. So for number 5, it says draw the reactant for process number 1, which was calcium chloride. Use an arrow to indicate the bonds that must be broken. So remember, y'all, back in the third 6 weeks, we learned that ionic compounds exist as crystal lattice. So that's their structure. So I'm going to take a part of that crystal lattice and just draw the lowest ratio between calcium and chlorine. So that is 1 calcium to 2 chlorine. So I'm going to draw that right here. And if we remember the structure, cations are smaller than anions. So the small one is calcium, and the bigger ones are chlorine. So the bonds that must be broken would be the ones between calcium and chlorine, and there are 2 bonds there. One bond here and the other bond there. So 2 arrows. Number 6. So it says, draw the water to ion attractions that result in process number 1 after the bonds have been broken. Draw an arrow to indicate where the new bonds has formed. So here, the product, calcium ion, chloride ion. So since calcium has a positive charge, we know the negative side of water, the oxygen side, will be facing the calcium ion. I'm just going to draw 3 water molecules here. There may be many surrounding it, but I'm just going to draw 3. And then the new bonds, y'all, can be found here, here, and here. The point where water is touching the ion. Now for the chloride ion. We know that chloride is -1, and so that negative charge is going to attract the positive side of water. So we're going to draw the water with the hydrogens facing chloride. Okay, so the bonds, I'm just going to draw it for each hydrogen, y'all. Okay, there you have it. Then we're going to go on to number 7. Identify each process as either endothermic or exothermic. So, when we are referring to a process, it's just the reaction that we made. So the dissociation reaction in part 1 and the dissociation reaction in part 2. So I'm going to label it process 1. Process number 1 was dealing with calcium chloride. And if we look at our data table, we know that there was a release of heat, or the temperature got hotter. So we know that this is an exothermic reaction. And then process number 2 was ammonium chloride. And here we saw that the temperature decreased, so we know this is endothermic. Cool deal. Let's move on to number 8. So number 8 says, explain why a reaction is considered endothermic in terms of the amount of energy used to break bonds in the reactants and the amount of energy released when new bonds form in the products. So, a reaction is considered endothermic when more energy is used to break bonds in the reactants than energy released when new bonds form in the products. Two key concepts here, y'all. Again, energy is absorbed to break bonds, so energy release when bonds form. Okay, so this was just a summary statement here, but the most important part was the sentence above it. Okay. The opposite is true for exothermic. A reaction is considered to be exothermic when more energy is released when new bonds form than when energy is used to break bonds in the reactants. Okay, number 9, the heat transfer that occurred in reaction number 2. Okay, so we're going to describe that heat transfer. So I'm going to draw that out for y'all. We have our calorimeter. And then using our X-ray vision, we know that the salts are here. So I'm going to zoom in on this, y'all. Okay, so the surroundings would be the water, and since reaction number 2 or process number 2, the ammonium chloride is considered to be endothermic. That heat is going to go from the water into the salt. Okay, so I'm going to write in words now. Heat is transferred from the water to the salt. Okay, we're done with our post-lab analysis questions. We're ready for the assessment. Good luck, y'all.